There it goes. Okay. So last time for the homework, I had one question towards the end of the homework that I realized I don't think we had gone over yet. So I promised that we'd talk about that today. I had originally planned to talk about separable differential equations, not today, but next week. It's sort of the last week of the summer. So I'm doing this a little bit out of order, and next week we'll go back and do the unit circle related rate stuff. So kind of the derivative review that I would normally do before this. When we come back and start doing classes in person, we'll start going through some formula quizzes. We'll review some of the stuff we've done over the summer and then start testing on that. Eric. Okay, Eric, I'm going to do a quick mic check. Can you hear me? Cool. Okay, so jumping right in. So a separable differential equation is any differential equation, which just means an equation involving a derivative, like this one that I have down here. So the derivative of y in terms of x is equal to 3e to the x over y squared. So if we have a differential equation, an equation involving a derivative, that we could separate so that both sides of the equation have only one variable. So right now we could cross multiply, and if I did, all of my y's would go to the left side and all of my x's would go to the right side. So if we can do that, we call it a separable differential equation, and separable differential equations are really nice because we can just integrate them normally. If we can't separate our variables like this, so if I still end up with some x's and y's that are mixed on the right side and some x's and y's that are mixed on the left side, something like an equation like this, dy over dx is y minus x squared. This is not a separable differential equation, because even though I can get dy minus y equals negative x squared, I would have to multiply through this dx by every term. And so when I do, I've got a mixed term here that I can't get rid of. So if I've got a separable differential equation where I can move all y's to one side and all x's to the other, then we can integrate normally after we've isolated our variables. That means after we've moved all y's to one side, all x's to the other. Separable differential equations have two different types of solutions. The first one is what we call a general solution. So that's your answer that has a plus c in it still. What that means is there is more than one answer that has this particular slope. There's more than one equation that has this particular slope. In fact, there's infinitely many equations that have this particular slope. But all of them will share a set form, which we'll see in a minute, which could have some number plus c in a particular place of our answer. That's our general solution. But we could also have a particular solution if we want to both have this slope and pass through a point, in which case there's usually only one answer, although for some equations we might have a limited set of answers, so like 1 or 2 or 3 equations that will fit. In order to solve for a particular solution, I'm going to take our general solution, so that's our equation we'll solve for that has a plus c in it still, and then plug in our x and y so that we can solve for that plus c. Once we know what c is, we'll go back and rewrite our general solution so that it doesn't have a plus c anymore and it will become our particular solution. Any questions on what we're doing or our vocabulary? Okay, I'm going to run through an example really quick. So for this example down here, our first derivative is equal to 3e to the x over y squared. And we're also given this point where whenever x is negative 1, y is the cubed root of 2e to the 30 plus 9e squared over e. Okay, so I've got the differential equation I was given. What I'm going to do is I am going to separate these variables by multiplying both sides by y squared and multiplying both sides by dx. So my dx will cancel on this side, my y squared will cancel on this side, and I'll be left with y squared dy equals 3 e to the x dx. And the way of thinking about this is we just cross multiply. Okay, now you'll notice on the left side is only y's, and on the right side is only x's. That includes for our derivatives. This is just dy, and this is just dx. So we've isolated our variables completely. That means we can integrate normally. Only for the left side I'm integrating in terms of y, and for the right side I'm integrating in terms of x. So if we integrate y squared in terms of y, I'll get y cubed over 3 plus c. And if I integrate 3 e to the x dx, 3 is a constant I can pull outside the integral. If I integrate e to the x, I get e to the x. This is 3 e to the x plus c. Any questions up until this point? Okay, that was the hard part. The rest of this is just algebra, although my next step is a little bit confusing because this c that I have on the left is not necessarily the same constant as this c on the right because they both came from different integrals. So this c could be 1, this c could be 3. Both c's could be 0. We don't know yet. So when I go to subtract on the left side, c minus c, because that's the same constant that I'm subtracting, this c minus c will be 0. And I don't need to write it. But on the right side, I'm subtracting this right c minus our left c, which is not necessarily the same constant. So I'm going to end up with some constant I don't know. It could be 0, but it doesn't have to be. Okay, I wouldn't say this is the hard part, but I would say this is the most confusing notation part. Are there any questions on what happened here? Okay, hello Niall, can you hear me? Cool. And I'm not sure when you came in, so I'm going to really quickly run through this up to where we are. Since we're still on the first example. Okay, so what we're doing is we're solving what's called the separable differential equation. All that means is this is an equation that has a derivative in it. It's separable because I can move all the y's to one side and all the x's to the other. So I'm going to start with what I was given. I'll cross multiply to make all of my y's on one side and all of my x's to the other. That allows me to integrate directly. I can't integrate if I've got mixed variables, so some x's and some y's directly yet. We'll need to use other techniques later in order to do that, but for now, in order to integrate, I have to have everything within my integral be only one variable, which is what I've done here. On the left side I only have y's, and on the right side I only have x's. That means I can integrate them independently. I'm going to integrate y squared dy to get y cubed over 3 plus c using our power rule of integration. And on the right side, I'm going to integrate by working backwards with our derivative. If I derive e to the x, I get e to the x. If I integrate e to the x working backwards, I should still get e to the x. So if I integrate 3 e to the x, I'll get 3 e to the x plus c. Okay, Niall, any questions up until here? Okay, my next part's the most confusing part for notation, but is not that hard mathematically. So these plus c's that I have here both mean they're plus some constant that we don't know. But they're not the same constant because they both came from different integrals. So the one on the left could be 3 and the one on the right could be 4. Or they could both be 0. We haven't proven yet. So when I go to subtract this left c from both sides, on the left this is the same constant. So when I subtract the same constant from itself, I'll get 0. But when I subtract the left constant from the right constant, I'll still have a constant remaining because they're not necessarily the same number. Okay, that's the hardest part notation-wise. Are you okay on this step? Niall, are you okay? Cool. Okay, then everyone's caught up. So from there, I'm just going to solve for y. So my first step, I'm going to multiply everything by 3. Again, when I go to multiply 3 times c, 3 times any constant is still a constant we don't know, so I can just write c. I'm going to keep that as just c all the way until the end. I can multiply, add, subtract, or divide any other constant by c, and it will still be c. Okay, then I've got y cubed equals something, so I'm going to take the cubed root of both sides. If I do, I've got y equals the cubed root of 9e to the x plus c, where c is a constant we don't know still. And that becomes our general solution. Okay, this is a general solution because I have solved for y. So we have solved the differential equation. It's still general though because we have a plus c. This is not one equation, this is a family of equations. Any equation that is in this form, where c could be any number you want, when you derive it, will give you this slope that we started with. Okay, any questions on what we mean by general solution? Or what we have so far? From anyone? Okay. So we were originally asked to find a particular solution that had this slope and passed through this point. So now that I have a general solution, what I'm going to do is I'm going to take the point that we were promised this equation will pass through, and we'll use that to figure out which particular solution out of these infinitely many general solutions is the one that both has the derivative we want and passes through the point that we want. So what I'm going to do is I'm going to take the point that they gave us. Y is the cubed root of 2e cubed plus 9e squared, all divided by e, when x is negative 1. And we'll plug that into our general solution to find our particular solution. So I'm going to substitute for y. Instead of y, I have our y value that we were given. And instead of x, I have our x value that we were given. X is negative 1 when y is cubed root of 2e cubed plus 9e squared over e. And then from there, we can solve for our particular c. Which constant do we want that passes through that point? Okay, so I've got some crazy cubed root things happening here. So what I'm going to do is I'm going to cube both sides to get rid of those cubed roots. So if I cube both sides, cube and cube. If I cube a cubed root, then my root will cancel. If I cube a cubed root, my root will cancel, but on bottom I also have to cube that e, so this will become e cubed, which leaves me with no root here left anymore, so everything that was underneath the root and e cubed, and no root on the right side either. Okay, then from there, I still want to get c alone. So what I'm going to do is I'm going to divide everything that's on the left side by e cubed just to simplify. So 2e cubed divided by e cubed is 2, and 9e cubed divided by 9e squared divided by e cubed is 9e to the negative first power, which gives me a 9e to the negative first power both on the left and right sides of the equation. So I can subtract that from both sides, and I'll be left with c equals 2. Any questions on my algebra? Okay, so now that we've solved for c, what we can do is I can plug this c back into our general solution, which would tell us as long as when x is negative 1, our y is this y value, our c would have to be 2. So our particular solution, the only solution of these infinitely many general solutions that also passes through our particular point, would be y equals the cubed root of 9e to the x plus 2. Okay, last call. Any questions on anything we did? Okay. I'm going to jump back to our homework and call in people who weren't there for the office hours. And then I'll jump here for people who were here for the office hours, and we'll do one of our AP questions together. So homework from last week that we couldn't do. Okay, given our differential equation, dy over dx is y squared 2x plus 2. And our initial condition, f of 0 is -1. I want to find the particular solution to this differential equation. Okay, if I remember right, I think Kyle and Niall were the only ones in the office hours last week. I have a hard time remembering. I know Kyle was there for sure. So I'm going to start with Andrew, and we'll go down the list from there. Andrew, if I want to find the particular solution to this differential equation, what's the first step that we have to do? Okay, what's that going to look like for us? Okay, right now I still have mixed variables, so I need to do one more step in order to get all my y's to one side. If I divide both sides by 2x plus 2 dx, that moves all my x's to the left side, but that leaves me with x's and y's on the left side. So I should divide by something else. Perfect, okay, so if I divide by y squared right now, then in one step instead of two, I can get all y's on one side and all x's on the other. Okay, I should also point out, in order to integrate, I have to have that dy or dx on the top of your fraction. If you've got it on the bottom of your fraction, we can't integrate unless your derivative of your variable is at the end of your integral. In order to integrate, I would have to have this dx here, not 1 over dx. So right now my only option is to divide by y squared, because that's what would give me my dy on top and dx on top. Okay, any questions, anyone on our first step? Dy over y squared is equal to 2x plus 2 dx is what we got so far. Okay, moving over to Eric. What can I do with this? Integrate, perfect. So my ultimate goal is to solve for y, which means we would not have any differentials left in our equation. We would not have any dy's, we would not have any dx's. So I'm going to integrate both sides, and if we integrate both sides, I'm going to rewrite this so that I can write this in power rule. How could I rewrite 1 over y squared so that we can solve it using power rule instead of quotient rule? Okay, I think you're one step ahead of me, so I think you're integrating already. Can you say that one more time? I'm sorry. Okay, so you're actually 2 steps ahead of me. I would normally have a plus c on this side as well, and you're right that I don't have to write it. because I can always move that plus c to the other side, and it would combine with the plus c that I have from the opposite integral. The c's can't cancel because they came from different integrals, they're not necessarily the same constant. Any questions on how we got here from anyone else? Okay, just for the sake of our recording, that integral that we did on the left side, I added 1 to the power, then divided by the new power, so that was negative y to the negative first power, and I can simplify that into that fraction. Okay, moving over to Kelly. Kelly, I need to solve for y, so what should I do next? Okay, before I can do that, I still haven't actually solved for y yet. So we don't have a general solution yet. Should look at both sides. Okay, I didn't need a natural log when I integrated, so I could take the natural log of both sides, but that wouldn't help me reduce this at all. So I would still have natural log of negative 1 over y. I want to make it look like y equals something. Okay, cool. So what you did there was you flipped both sides, which is okay. So that would give me negative y equals 1 over x squared plus 2x plus c, and then you divided both sides by negative 1, which is great. Y equals negative 1 over x squared plus 2x plus c. Okay, that's awesome. And then you did mention what the next step would be. So you told us the next step would be to plug in your point. So I'm going to do that. I'm going to jump down to, I believe we've gone through everyone who wasn't here, so I'm going to jump down to Kyle. We have our general solution right here, but they actually asked us for the particular solution that passes through a point. So what do I do next? We find C. Okay, so how do I find C? Replace y. Okay, replace y with negative 1, replace x with 0, so that gives me negative 1 equals negative 1 over 0 plus c is c. Okay, and then we can solve for c. So, Kyle, I'm going to have you keep going. What is c? Awesome. So the last step would be I need to plug that c back into our original problem, and I'll get our particular solution. So if I do, that would give me y is equal to negative 1 over x squared plus 2x plus 1 is our particular solution to this differential equation with the initial condition f of 0 is negative 1. Okay, I didn't get to Nile, so I'll start with Nile on the next one. But any questions on C? Oh, Nile, I'm showing your mic live, but I don't hear anything. So, do you have a question? Okay. Cool. So I'm gonna jump into new stuff for today. So I'm going to do the first problem from your homework set with you guys in class, and then you guys have a couple more questions from the homework set to do on your own. Okay, so at the beginning of 2010, we have a landfill that had 1,400 tons of solid waste. The increasing function W measures the amount of total solid waste that's stored at the landfill. The planners estimate that W will satisfy the differential equation dW over dt equals 1/25 of W minus 300 for the next 20 years. W is measured in tons, and T is measured in years from the start of 2010. Oh, okay, just got a warning. Our meeting is going to end in 10 minutes. When it does and it breaks, I'll need you guys to click the link again through WeChat. Okay, so we're going to use the line tangent to the curve at W at t equals 0 to approximate the amount of solid waste that the landfill contains at the end of the first 3 months of 2010, at the time t equals 1/4. Okay, so for part A, I want to get a line tangent to the curve at t equals 0. If I want a tangent line, so this is from the previous week, what would my equation of a tangent line be? Okay, so what I have here is the general equation of a line in point slope form, where I've got one point AB and a derivative, which would be our slope, which is f prime A. So in this case, using our notation for the solid waste, I should have 1 point right now, which is at t equals 0. Which means if t is measured in years from the start of 2010, what time really is t equals 0? Rephrase. T measures how many years from the start of 2010 have passed. So if t equals 0, then what year are we talking about? 2010, okay. So when t equals 0, we're really at the beginning of 2010. Okay, so for my point, my x value, so that's the time that's passed right now, my t is 0. And how many tons of solid waste were there when t was 0? $1,400, perfect. And because t is 0 at the beginning of 2010, and at the beginning of 2010, a landfill contained 1,400 tons of solid waste. Okay, and then my derivative would be, instead of f prime, I've actually got a w for our equation. I'm going to leave our general form like this. I'll just write down here maybe. So this would be for us, my y value is w minus our b value is 1,400 is equal to the derivative, which would be w prime at the t value 0 times t minus 0, where w prime at 0 is dw over dt when t equals 0. Our dw over dt doesn't have an equation for or doesn't have t in its equation, but it does have a w in its equation, and we know what that w was. So I can plug that into our differential equation and still get an answer for w prime at 0. Which I'm going to do right now. So therefore w minus 1400 is equal to my derivative when t is 0. When t is 0, my w is 1400. So my w prime then would be 1 over 25 times 1400 minus 300. Times t minus 0 is t. Okay, any questions on what we've done so far? Zoom out so we can see the whole question again. Okay, so that gives me 1100 divided by 25. Times t is equal to w minus 1400. Divided by 25 is 44. So you have to solve this for slope-intercept form. It's not okay. I actually don't have to solve for slope-intercept form, so I could just stop right here since I am in point-slope form. If you do want to stop in slope-intercept form, y equals mx plus b, then I can add 1400 to both sides and get this. The equation of a tangent line to the graph at w at t equals 0. That will allow us to estimate the amount of solid waste using our point that we started with and our slope at that start point. This is just an estimate. It doesn't actually curve like our real function does. But it should give us an idea over this 1/4 of a year. If I stayed with that slope that we had at the beginning of the year, how much solid waste would we actually have? Okay, so I'm going to use this equation to make our estimate. Okay, not sure what happened there. There we go. Okay, I'm going to use this equation to make our estimate. I want to estimate what's going to happen to w when t is 1/4. So I can say our estimate would be w when t is 1/4 would be roughly equal to 44 times 1/4 plus 1400. Or 11 plus 1400 is 1411. Okay, what are my units, Andrew? zoom out again. Can you guys still see, or is that too small? Okay. Perfect. We're making an estimate for W, so that's still tons of solid waste. Niall, what are the units for dW over dt instead? Per time, right? What's time measured in? You're right, but what is the unit of measure for time for us? Not months, no. Oh. Welcome back. Okay, sorry now, cut you off there. So, no problem. So you're right, dW over dt would be measured in tons of solid waste per year. So our derivative is really measuring the change in the amount of solid waste each year, which is still a useful metric. Okay, that's it for part A. Any questions on A? Okay, I'm going to jump down. Yes. Oh, I always forget to reset that. 1 second. There we go. Okay, so one more time now that we can see. Any questions on part A? Okay, I've got some notation we haven't seen for part B in quite some time. So part B says I want to find the second derivative of W in terms of t. And because our first derivative of W in terms of t involves a W, when you derive, your derivative will also be in terms of W. Okay, so I believe next is Eric, if I'm not mistaken. So Eric, jump down here. Give us a bunch more space on the next page, actually. So I'm gonna run out of room. Okay, so for part B, the first thing we need to do is we need to find the second derivative of w. What would you do to find the second derivative of w? Derive it one more time. Perfect. Okay, so let's go ahead and derive this one more time. And what would you get? Sorry, Eric, still on you? If I derive this one more time, what will I have? Okay, I've simplified, so I haven't actually derived, I've just distributed for you. So 1 over 25 by w is w over 25, and 1 over 25 by negative 300 is negative 12. So this is still dw over dt. What will happen if I derive this one more time? Oh. Okay, I can't hear him because he disconnected. Oops. Two, three, four. I'm missing 2. Oh, no, missing 1. I count there. Okay, I'm gonna keep going until he comes back. So next would be Kelly. What's my derivative? One over 25, perfect. Okay, I'm gonna stick with you for the next part. So I want to use this second derivative to figure out whether my answer for part A was an underestimate or overestimate. I think the easiest way to tell is to go ahead and draw a graph of what we did last time. So what we did last time was we took a point and we took a slope of our curve and we extended that out as a line. And we used that to make an estimate for what would happen after 1/4 of a year. Okay, but there was a real function there that we don't know anything about yet. Other than the fact that that function was concave up or down. Okay, concave up because our second derivative was positive. So we know the function was concave up. We also found in part A that our function was increasing on that interval. So if I was concave up, and I want to get from point A to point B, something like this, where in pink is my actual function, in black is our estimate that we had for part A. Do you think our estimate is going to overestimate or underestimate? So I need to be concave up and increasing. What do you think? Okay, so our estimate was too high. Okay, so our answer for part A was an overestimate. Can you explain why? Okay, that's okay. So our estimate in part A was an overestimate because we were concave up and increasing. So I would have expected if my slope stayed the same, to make an overestimation. I'm just going to write because we were concave up on the interval. Our estimate in part A was an overestimate because we were concave up and increasing on the interval. More specific than that, not we were, but our function. So that's tons of solid waste. The tons of solid waste was concave up and increasing on the interval. Okay. Any questions on part B? Okay, I'm gonna double check myself really quick. Oh, got this one wrong actually. We were overestimating. Our slope is positive, so I'm increasing. Okay. Apologize. It's the same reason, but this should be actually underestimating for our curve. Let me redraw. Our slope isn't staying the same. Our slope is going up because our change in the slope would be my derivative and is positive. So my slope should be accelerating, not staying the same as I go. So my slope was here, and if I keep accelerating, I'm actually going to go up above that. Okay, my bad. Okay, so I am underestimating with our estimate because my slope was the same at part A, but my slope is also increasing from A to B. Where when we used our tangent line, we assumed that the slope would be the same for our estimate, when it's not. Does that make sense? apologize, I would have gotten that one wrong, I think. Okay, and then part C, what I'm actually looking for today. We need to find our particular solution to this differential equation with our initial condition. There we go. And next is Kyle. Okay, so Kyle, what's my first step to find the solution to this differential equation? Okay, so I don't have a fraction on this side. I guess I could if I distribute this. So when you cross multiply, what's going to happen? Okay, so I'm going to multiply dt and 25, so that gives me 25 dw, if you want to do it that way, is equal to w minus 300 dt. But I have mixed variables on the right side still, so what do I need to do? Perfect. So if I divide both sides by w minus 300, then I'll move all the w's to the left and I'll have all the t's on the right. This will be 25 dw over w minus 300 is equal to dt. Okay, over to Niall. What's my next step? Okay, clean up my handwriting here, not changing anything, but okay, my goal is to solve. I do need to remove the dw, but how can I get from this derivative to an original problem instead? Both of these d's stand for derivative. How can I undo a derivative? Integrate, perfect. So I'm going to integrate both of these sides. The reason why I can integrate both sides right now is because the entire left side only has w variables, and the entire right side only has t's. So because neither side is mixing variables, we can integrate directly. Okay, so I'm going to integrate this left side. I've got a constant 25, which I'm just going to pull out, because that's just going to make things more complicated. And any constant, if I derive, is going to stay a constant multiple. So any constant when I integrate will also stay a constant multiple. Okay, so that gives me this. Niall, for the left side, what do you think is going to happen when I integrate dw over w minus 300? What's going to happen when I integrate the left side? Okay, if we're not sure, is there anything that I could derive that would give me 1 over my variable? Okay, go for it. Yes. ln w minus 300 plus c. Okay, the reason why I can do that, we could use a u substitution here. If u is w minus 300, and this will be u prime over u. When I integrate u prime over u, I'd get natural log of u plus c. And I can resub back in for u. The reason why I'm doing that u substitution is because if this wasn't just w to the first power, if this was anything else, then I would have to have the derivative of that bottom part on top in order to use my natural log equation directly. Okay, but you're right. So this left side is 25 natural log w minus 300 plus c. On the right side, what's going to happen if I integrate dt? T plus c, perfect. Okay, and we're back to Andrew. Andrew, what's my next step? Okay, before I can solve for c, I need to solve for w. Okay, if I do, what's going to happen? Perfect, so only the left side because they're not the same constant. We haven't proven they're the same constant yet, so w minus 300 is equal to t plus c. If these had both come from the same integral, then we could prove they're the same constant and cancel, which is why they do cancel on the left. Okay, keep going. Cool, natural log w minus 300 equals t plus c over 25. Okay, now they did not ask us for a general solution here, they just asked us for a particular solution. So it would be okay to plug in your t and your w value at any point you wanted to. However, once you plug it in, your c is set at that step, which means you could still solve for w, and that will change what your c value ends up being at the end. So if you wanted to, you could solve for c here, and that would be okay. If you want to wait until the end and then solve for c, that would also give you a general solution, which might be more, it might give you more information if this is a real world problem. On your AP exam, it's up to you. If I was actually doing this one in the AP exam, I probably would have solved for c right away, just because everything is fairly simple right now. So that means I would have plugged in 0 for t and only got c on one side on this step. And that gives me 25 natural log of 1100 for c. I am going to keep going for now though, just because that'll give us a general form, and you're going to be asked about some of the general forms on your other questions for the homework. But if you did want to do this one as fast as possible, you should probably solve for c in this step, just because plugging in t as 0 right now gives you c equals something, which is about as simple as it can get. Okay, sorry Andrew, keep going. Okay. Yes. So what you've done really is you've raised both sides to the base of e. But e log base e will cancel. So that leaves me with w minus 300 on the left side. Okay, so after raising both sides to the base of e, my natural log will cancel, and I'll be left with w minus 300 equals e to the t plus c over 25. Last step, add 300 to both sides, and I've got w is equal to e to the t plus c over 25 plus 300. Okay, any questions on how we solved for our general solution for w? Okay, Kelly, you're up. Now that I know this general solution, how would I get the particular solution that passes through the point 0, 1400? Plug it in, perfect. Okay, so passing through the point 0 equals 1400. Okay, so what is w? Okay, so 1400 equals t is 0, so this is c over 25 for our power. So I've got e raised to the c over 25 plus 300. Okay, keep going. Okay, 1100 is e raised to the c over 25. Okay, so that gives me natural log of 1100 equals c over 25. Multiply by 25 is 25 natural log 1100 is equal to c. Okay, so that means what should my final answer for the particular solution be? Okay, so I'm going to try to simplify this a little bit because this looks crazy. So if I wanted to simplify this, what could I do? I'm not sure. I'm going to break up these two fractions first. So this will give me e to the t over 25 plus 25 over 25, which is 1, natural log of 1100 plus 300. See, Kyle, if I'm adding my exponents, what am I really doing? So if I had 2 to the 2 plus 3, that's this. Right, I'm really multiplying by the same base. Okay, so that's what I'm going to break this apart as here. So w is equal to e to the t over 25 times e to the natural log 1100 plus 300. Properties of logarithms. I've got e raised to a log of the same base. e raised to the log base e of 1100. Kyle still, what should this term simplify to? Close. Anyone? What should e to the natural log 1100 become? Perfect. So if I raise the power to the same base, then I'm actually undoing that power. So this will become 1100. So I've got 1100 e to the t over 25 plus 300 is as simplified as I can make this equation for w. Okay, lots of algebra there. And a little bit of pre-calc properties of logarithms, but any questions on what we did? Okay, so that leaves us 20 minutes to talk about how to do some of this graphically, which is okay since that's the easier part. I've got another 10-minute warming on Zoom. So last part for today deals with what we call slope fields. Okay, which I don't have a handout for. I'm going to quickly show a couple problems instead. Okay, so what I've got here is a bunch of different possibilities for one of these differential equations that I have listed here on the bottom. Right. Now you were running through AP Calculus AB stuff with me last year, I think, so you've seen all this before. So what we're really doing here is I'm graphing the different slopes dy over dx that would happen at these x and y values. And it'll match one of these multiple choice options. So what I would do if I was going to do this is I would look for points where our slope is either 0 or our slope is undefined first. So can anyone give me one x and y value where the slope is 0? Okay, at 0, 0, and 1, 1. dy over dx equals 0. Okay, so I'm just going to go through these and see if that's true. Can A be true then? Yes or no? Andrew? No, why not? You're right, but why not? Perfect, okay. So my slope would be undefined whenever y equals 0 if this was the actual slope. When we do have defined values for the slope. Also, if I plug in x is 1 and y is 1, I don't get 0, I get 1. So A is not it. Okay, what about B, Kelly? Can we eliminate it yet or not yet? Not yet, okay, because if I plug in 0, 0, and 1, 1, I still get 0, so I'm going to save B. What about C, Kyle? Okay, also eliminate. If I plug in x equals 0, I would get undefined, not 0. And if I plug in 1, 1, I would get -1 for that slope. So for both of these points, that doesn't work. And Niall, for part D. Okay, that's fine. So if D was correct, then whenever x is 0, the whole slope should be 0. But you can see all of these points where x is 0, but the whole slope is not 0, that's showing. So it can't be D. If you wanted to use just these 2 points that Kelly picked out, if you plug in 1, 1, my slope for D would be 1, not 0, which is the slope that we see at the point 1, 1. Okay, so not D, so that leaves you with just B. Okay, any questions on what we're doing right now? Alright, let's try one more. Okay, for this one, number 24. I started with Kelly last time, so let me start with Kyle this time. Kyle, what's the first point that you would test? Okay, 0, 1, I like that, because I know that this is 0, where I'm not really sure what these slopes are, it's not very clear. Okay, so I'm going to plug in 0, 1 into all of our differential equations for A, B, C, D, and see if any of these are not true. Okay, so Kyle, I'm going to stick with you on this one. Let me know if for the point 0, 1, dy over dx should be 0. If that's not true, say not true. Okay, for A. Not true, because if I divided by 0, I would be undefined, so it cannot be A. Okay, what about B? True. What about C? Okay, C is also true for this point, and D. Not true. Okay, so even just picking one point, we've already eliminated half of our answers. Okay, so now I'm going to look at this. Looking at answer B and answer C, is there any point that you would plug in for either B or C that would let you know which one is the right answer? One, 1. If I plug in 1, 1, I get -1 for B and I get -1 for C, so 1, 1 won't help me. Is there any x or y value you can see? Not even looking at the graph, but just looking at B and C. That would 1 and 0. Okay, so if I plug in 0 for y, if B is right, I would be undefined, and if C is right, I would get 0. Okay, so looking at our graph, when y is 0, what happens? When y is 0, is my slope does not exist, or is my slope 0? Okay, so right now it actually does not exist. I don't have any slopes drawn. But that is a little bit hard to see with the axis there, so maybe we can pick another point. Okay, so let's say for part B, though I do think that y equals 0 is the easiest part to see right now, if I picked something like 2, 2, what would happen for B for the slope? -1. Okay, what would happen for part C for the slope? -4. Okay, so C would get sharper. What if I pick 2, 1? Okay, so for C, I would have a slope that is more negative at this point than this point, which is not true. Okay, that can eliminate C. Again, if I was doing this personally, there's nothing drawn for 2, -1, 0, 1, 2 when y is 0. So I would have said if I plug in 0 for y, I'm undefined for B, but if I plug in 0 for C, I should get 0. If my slopes were 0, you would see something like this on the axis, so just straight horizontal lines. Whereas if it's undefined, you'll see nothing drawn. Okay. Says I am screen sharing, but I don't see a box. Andrew, can you see the screen? Okay. I do have this set, so my invite links aren't actually changing anymore, but throw that in just in case. Set up the next problem while we're at it. Okay, we got everybody back. Okay, so we just finished this one up. We said for differentiating between B and C, we could have looked at points 2, 2 and 2, 1 to see the difference in how sharp the slope is. If I would have gotten -4 as expected with C, then I would expect this to be a steeper decline than what happened at 2, 1. Although I do think it's easier to see, for me personally, looking for whether this is 0 or does not exist at the y-axis. If our slope is 0, you would see horizontal lines here. If our slope is undefined, you won't see anything drawn. Okay, any questions on 24? Okay, one more. Let's go. I forget. Andrew, have you done one yet? Or did I do Kelly first? I don't either, so I'm gonna have you do this one for me. Are there any points that you think that would be easier to test? Okay. Okay. Okay, at 1 comma 0, dy over dx is positive, which eliminates b. Okay. Okay, cool. If C was right, then all of these lines would look exactly the same, right? Okay, so this one should be D. Okay. So the way this is going to look on your homework is I'm going to give you a blank series of points that look something like this. So point 1, 2, 3, 4, 5, 6, 7, 8, 9, and some sort of a differential equation. So let's say dy over dx is equal to y over x. And I'm going to ask you to sketch the differential equation. So I want you to sketch the solutions to the differential equation. So what I'll need you to do is I'll need you to plug in values for y and x for all 9 of these points, figure out what the slope would be, and then draw that slope through the points. So for example, whenever y is 0, my slope is 0 unless x is 0, and this is undefined. So I'm going to draw here in red maybe. Okay, my slope is 0 for -1, 0. My slope is 0 for 1, 0, and my slope is undefined, which means you don't have to draw anything, for 0, 0. Okay, Kelly, what is our slope at -1, 1? Okay, at 1, 1 you said we are positive. What about -1, 1? So at this point, okay, -1, so something like this. What about at 0, 1? Undefined. Okay, cool. Niall, what would this slope be? Okay, +1. What would this slope be? Not 0? undefined, so I don't have to draw anything. And last point. Okay, cool. Does everyone understand what we're doing? Any questions on what we're doing from anyone? Kyle, go for it. You're drawing the slope at these points is what I'm really doing. So you can find out the slope dy over dx by plugging in your x and y value for each of these points. And then you'll draw a short line that has that slope. Okay, so what this actually means is you're sketching a field, so that's a graph, of every possible equation that would have this slope. So there is one equation that has this slope that would pass through, use one of the computer examples because these are a little bit more accurate. There's one example that would have this slope that would pass looking like this. But if our plus c was different, that would add to our y value and raise the equation, right? So there are infinitely many answers for the actual equation that would have the slope of x if you derive it. If I integrate x, we'll get x squared over 2, which is a parabola type shape, plus c. That plus c means this could be x squared over 2, a parabola plus shape, parabola-like shape, plus 1, which would mean I'd raise that x squared over 2 by 1 and get this particular parabola, which I'll draw here in orange. Okay, so these slope fields are really graphing every possible equation, y in terms of x, all in the same graph. Okay, any questions on what they represent? Okay. So I am 1 minute over time, and I apologize. Actually thought this would be a faster lesson. It ended up being the slowest one so far. If you guys have further questions, let me know on WeChat. The homework is posted to WeChat already, and I'll get on posting that to course sites after we break here. Thank you guys so much for coming, and I will see you for office hours if you want. Problem? Yes. I have not checked the free response questions yet. Make sure I've got yours though. Okay, I have Kyle's from WeChat. And I believe that's it from WeChat actually. So everyone else should have submitted through course sites, but I actually haven't downloaded that yet. Oh, okay. Let me check on here too. From August 8th. Okay, that's the week before last, I think. Okay, so this is just an effort key you did on your own. Okay. I can send you the scoring guide for that if you want, so you can score yourself. 1, 2, and 3. From 2005. Okay, and these are AB or BC? Okay. One second, downloading from College Board now.